Okay, so we're just gonna take some time going over page 93, question 9C, and then I wrote it down here. What we're trying to do is to solve for x, right? Well, how do we do that? Well, what do you think the strategy we're gonna do first? Yeah, so why are we squaring both sides? Yeah, to get rid of that square root right there, right? So let's do that. So square both sides, square both sides. So if we square all of these, right, that's going to be 3 squared is 9. And then this squared would be, that's going to be 2x plus 1. Okay. Now what about this one here? X plus 4 squared. It's going to be x squared plus 8x plus 16. Okay. So this is the fast way of doing that is you square the first term, so that will give us the x squared. The middle term would be first term, and then the second term, so that's going to be 4x times 2, doubling it up. So that's going to be 4 times x is 4x times 2, 8x. And then last term would be 4 squared, which is 16. Okay? Now, what are we going to do next? Well, let's bring in expand this one here. That becomes 18x plus 9 equals to x squared plus 8x plus 16. Okay. Now, it looks like we're going to end up with a quadratic equation, right? Because we can't isolate the x by itself. We're going to end up with a quadratic equation because we have the x squared. So what we could do, there's two strategies that we can use is factoring strategy or quadratic equation strategy. Okay, so bring everything on one side. So that becomes 0 equals to x squared plus 8x plus 16. I'm showing all my work here. And then bring the 18x to the other side of the equation, and then the 9 to the other side of the equation. So that makes it negative 18x and then minus 9. Okay. And of course, we're going to do the collecting of like terms. So x squared, these two are like terms, so we can combine them. So it's going to give us negative 10x. And then these two, 16 minus 9, that's going to give us the 7. Okay. Now looking at this one, is this even, can we solve this by factoring? No. Okay. How do you know no?
It's not factorable.
How do you know it's not? The odd number, right? Because there's no factor of 7 that would add up to minus 10, right? So this is not a nice factorable polynomial. So what's our strategy? So we realize it's not factorable, so we're going to use the quadratic formula. Okay, and what's a quadratic formula? X is equal to negative b plus or minus root of b squared minus 4ac. All of that has to be divided by 2a. Okay, oh wow, you guys are amazing. You remember this. That's probably from grade 11. So these ones here, the a, b, and c, are basically the coefficients of the quadratic here. So a would be 1, b would be negative 10, and then c is 7. So this is really the formula. So negative b, so negative b, so that's going to be negative negative 10, so that makes it positive 10. Plus or minus root of b squared, so negative 10 squared, so that's 100, minus 4 times 1 times 7, so that minus 28, divided by 2 times a, which is 1, so 2. Yes? So far so good? So x is equals to 10 plus or minus root of 72 over 2. Okay, good. So now I can see that there are two possible roots. There are two solutions to this. The discriminant is positive, so that means there's two solutions, right? Positive. So first solution would be x is equals to 10 plus the root of 72 over 2, whatever that is, right? Oh, 72, thank you.
Or we can say 36 times 2.
Or, oh yeah, you could do that. You could simplify the radical, yes. Yeah, you're right. Or, here's the other one, 10 minus the square root of 72 over 2. Okay. So I can see like some people were saying that, hey, I could 10 plus root of 72 would be root of 36 times root of 2 over 2. So 10 plus 6 root 2 over 2. Or you can say the other one's the same thing. X is equals to 10 minus 6 root of 2 over 2. And what else can we do? If you want to really simplify it further, like down to the very simplest form, there's a common factor here of 2. We can factor that out. So it's going to be 2 times 5 plus 3 root of 2 over 2. And then a common factor of 2 cancels. So x is equals to 5 plus 3 root of 2. And then the other one, it's almost exactly the same there, except that it's negative. So it's 10. Oops, sorry. I said it's going to be the same. So it's going to be 5 minus 3 root of 2. So these are your two solutions. And these are the exact value. Yeah? Okay, so those are great stuff. I really like how you remembered quite a bit from your previous math life. Okay? And then whatever that decimal value is, that's what it is. Okay? So that's 7C. 7C. Or, 9C. Yes? Now we're going to do 9D. Is that okay? Okay, this is 9D from the same page, page 93. I'll write it out first. Oy, this is really bad. Wow. Oh, interesting. Okay, what's our strategy here? Yeah, what we need to do is we need to somehow square it. Okay, let's see what if we square these things. Okay, so once we square this is a binomial. You can think of it as a binomial, something plus something squared. So when we expand this is going to be 1 squared is 1. This times 2. Is that okay? Yeah? Okay. Tell me if it's too fast. So 2 root of x minus 3. And then squaring of this, it's going to give us plus x minus 3. I'll just put it in the brackets because I don't really have to, but okay, what about this one here? Oh, this is kind of nice because everything is under one radical, so it's going to be square root of 2x minus 6 squared. That's just going to be 2x minus 6. Yes? Where did I get the 2 from? Okay, that's a good question. So I'll do it in a separate page, okay? Do it in a separate page. So 1 plus root of x minus 3 squared means, right? Is that okay? So if we were to firsts, outsides, insides last, then you're going to have 1 times 1 is 1. 1 times that will give us root of x minus 3. And these two is another root of x minus 3. And then x minus 3 for these two. Right? It's going to be x minus 3. So the question was this part here, right? It's root of x minus 3 plus x root of x minus 3. Now you're going to have 2 root of x minus 3. Okay, so that's why there's 2. Is that okay? Yeah, okay, good. So now, what are we going to do? We can probably clean things up in here. So it's 2 root of x minus 3. Combine like terms, so it's 1 and a negative 3 there. So x minus 2 equals to 2x minus 6. Okay. This one I could probably bring it to that side to combine like terms. So I can say 2x minus 3 equals 2x minus 6. And I bring this side over there. Okay, hope I'm not making a mistake. So 2x minus 6, bring this to the other side so it's negative, and then that's positive. So far so good. So now it's 2x minus x. We got x. Negative 6 plus 2 is minus 4. Okay. Now we gotta, there's one more radical that we have to deal with, right? So that one. We gotta square it again. So that gives us 4 times x minus 3 equals to, here again, x squared minus 8x plus 16. Okay? Expand this a bit. So 4x minus 12 equals to x squared minus 8x plus 16. Okay, almost there. Looks like we're going to have a quadratic equation. Okay, so bring everything to the other side. So 0, x squared minus 8x plus 16. If I bring this to the other side, this is going to be minus 4x. If I bring that to the other side, that becomes plus 12. So x squared minus 12x. And then that's going to give us 28. Okay, good. I see. Is there any factor of 28? Is this going to be a factorable thing? Is there any factor of 28 that adds up to negative 12? So 20. Okay, so 28 would be 1 and 28. 2 and 14. 2 and 14. Oh yeah, but it's plus. So it has to be plus and plus, plus and plus. Minus 14 and it has to be
All minus.
It has to be all minus, right? Because this is a positive. Yeah, positive times positive. So so 4 4 and 7? Negative 4, negative 7? None, right? So it's not a nice factorable thing. Yeah, 4 and negative 7 is not going to work. Okay, so not factorable, we have to use a quadratic formula. So x equals to negative b plus or minus b squared minus 4ac. So negative b, so, which is negative 12, that's positive 12, plus or minus b squared, so it's going to be 144 minus 4 times a, which is 1, times 28, so 4 times 28, that's going to give us 32, 8, 11. Divided by 2a. So x is equal to plus or minus. It's going to give us 2, 32. Oh. 2. Oh, I forgot the a. It's 1, so it's just 2. So we get two solutions again. It's going to be 12 plus or minus root of 32 over 2. So this one here has perfect square factor, so it's going to be 12 plus or minus has 16 times 2, so it's going to be 4 root of 2 over 2. Common factor here of 4, so it's going to be 4 times 3 plus or minus root of 2 over 2. Okay, there's a common factor of 2, so it's going to be 2 times 3 plus or minus root of 2. So, yeah, it's not a pretty number, it's not a nice, it's an irrational number. And whatever that decimal value is, and that's our solution. Yeah? Is that good? Are you able to follow that? Yeah. And of course, I'm going to post it. What about C? Yeah, right here. You want to see the...
Why don't you express in decimals?
Oh, B. What about the B? Okay. Now there's this part here. What about the B? Are you talking about this B? Are you... Are you asking about this B? Okay.
This one, the first one.
This one?
The first one.
This one?
No, the first one that you did before.
Oh, the first one that I did before, 9C. 9C, right here.
Yeah, in the answer, final answer. Can you simplify it?
Mm-hmm.
Then it's going to be root 2. Just 5 you can simplify it. You can express it in decimal, you can express it in decimal.
Yeah, you can express it as a decimal. Yeah, you can express it as a decimal. Okay, so do you still want to do number 9B? Do you still want it, Awet? Yeah? Okay. Okay, yeah, this is really good. What do you think is the first strategy? Okay. Yeah, now I'm probably thinking, oh yeah, I'm going to do square both sides.
After 4, 2x minus 2 times radical n minus x.
Yeah. Yeah. Here's what we could do is, because if I start squaring this right away, this is gonna get messy. You're gonna have like square, right? It's messy. So here's a strategy. I'm gonna take this 2, bring it over there. So it's gonna be x minus 2 equals to square root of 4 minus x. So now when we take a look at the squaring, if we square it, now we can square both sides. So it's going to be x squared minus 4x plus 4 equals to 4 minus x. Bring everything to one side set it equals to 0. Okay, so this looks like it's cancelled. This looks like x squared minus 3x equals to 0. Okay. How can we solve this one? Well, we can solve it by factoring or quadratic formula. Common factoring. So x minus 3 equals to 0. So we have zero product property. That's what we're trying to do here. So what will make this factor 0? X equals to 0. And what makes this factor equal to 0? 3. Okay. So now, the thing about this one here, it's nice, but we should have verified our answer. We should verify our answer. So if we put in 0 here, if we verify 0, 4 minus 0 is 4. Square root of 4 is 2. 2 plus 2, is that equal to 0? No, it's going to be 4. So this is going to be, yeah, that one is extraneous solution, not a solution. The solution. Now what about this one? X is 3, so we're going to plug in 3 there, and then we're going to plug in 3 there. So 4 minus 3 is 1. Square root of 1 is 1 plus 2 is 3. So this side is 3, and then this side is 3. So that means this is a solution. Okay, is that good? Anything else that you want us to take a look at? Anything on the other page? The ones that were given to you. Have you done this one here, number 12? Number 10? Okay. We'll try number 10. So this is page 94, question 10. Okay. Given the graph, okay, for the graph of the cubic function y equals to g of x below, so this one, we don't even know what the function is. This is where, this is what the, oh, yeah, I'll give you a moment to work together, Abraham. Oh, Abraham, I'll give you time to talk to each other in a second. I'll just go over this together. Yeah, okay? Just so that everybody is able to focus on this one. So it says here, you're given the graph of this. Okay, we don't even know what the function is. We know it's a cubic function because it has that S shape to it. Sketch the graph of the square root of g of x. And this is the one that we were kind of looking at. So if you want, this is a strategy. This is a strategy. You can say x, f of x, that's really the y value of this original function. And then you take the square root of f of x, right? Because that's actually, to be technically correct, it's supposed to be g of x. G of x, I gotta pay attention to that one. So looking at this one in here, this is my original graph. What values of x, what are the points? So these ones are the coordinate points, right? So what points do you see?
X is 0, G of X is 1 and 1.
Yeah. So let's start from left to right then. So we can, what is this point right there? -2, comma, what's the g of x? So this is going to be the scale is every 2, right? So 2, 4, 6, 8, 12, 14. Because the scale is every 2. So that's going to be, this is 12, this is 14, the other one's 15. Yeah, be careful with the scale. So, okay, this is 2, okay, it's 2, 4, 6, 8, 10, 12, 14, and then this is 16, because the scale is 2. We can't just assume that and that's why they have the scale in here. So that's 15.
Please excuse the interruption. Would the owner of the vehicle HZB383 please come to the office?
Okay.
License number HZB383, please come to the office.
Okay, what else do you see in here? That's nice. Yeah, -1, 0. Okay, what else do you see? 1, 0. And then 2. What is this? 2, 3. 2, 3. Because remember, it goes up by 2's. Okay, good. Now, it's very interesting that you didn't even pick any point in here. Anything below, you cannot take the square root of, right? So scratch that off. So over here, what are we going to do? We're going to take the square root of g of x. So square root of 15. What's the square root of 15? It's going to be 3.9?
Yes.
Okay. Okay. Now, square root of g of x is 0. 0. The square root of 3 is 1.7. Okay. So, what's our point there? -2, 3.9. So, -2. Where's 3.9? So, down here. Okay, so this is the one that we're looking at now, this combination, because this is the x, and then this is the square root of g of x. -1, 0, so that's this invariant point there. 1, 0, that's this invariant point there. And then 2, 1.7. 1.7. Okay. Where are the invariant points? I'm gonna make it a little bit closer, or a lot closer. Okay. Where are the invariant points? Invariant points happen when the f of x is 0 and f of x is equal to 1. Okay, invariant points. Where's the invariant point? So this is 2. So this is the invariant point right there. Really, really tiny. So it's gonna go like this way. I'm trying to make a loop there. So that's that. And then this one here, the invariant point is 1, so it's right there. It's really tiny, so it's gonna go like this one. And then this one here, the invariant point is gonna be something like this. Oh, this is really... So the graph looks like this one and this one. You got the 2 piece of it. Okay? So that's what the graph looks like. Good? So far so good? Okay, and then if you're, if you've tried the B, great. If you haven't tried the B, you can give that a try. Have you tried question 11?
We will not connect photographs.
Hmm?
We don't need to connect photographs.
No, this is gonna be disjointed because this part here is above, right? So that we can take a square root of that. But this part here is below the x-axis, so it's negative. We can't take the square root of a negative y value. This one, no. So it's just this part and this part. No, we're not connecting those. Did you try 11? Sketch the graph of a linear function for which the square root of g of x is not defined. So can you think of a sketch or a graph of a linear function where completely not defined everywhere? Thank you for reminding me. Yeah. Okay. So where is it that's not defined? Sketch a graph.
So the first one said state the range and
So it's completely not defined. Remember, the graph of the square root of g of x is not defined when everything is below the x-axis, right? So here it is. Because if this is a g of x below the line, below the x-axis, and if we take the square root of that, everything is not defined. Okay? Now think about that for letter B. Sketch a quadratic function where f of x is not defined. Can you think of one that's not defined?